In this video, I want to show how to solve a system of equations by hand. Notice that we have 3 equations and 3 unknowns. I like to use the notation of E1, E2, and E3 to represent my different equations. So I'll say E1, E2, E3. I believe that this helps keep your work organized as you try to work through the problem. And so the first step, as I look at these 3 equations, what I want to do is get one of these coefficients to be 1 for the x. So I want to reduce them down to where I just get x or 1x as a leading coefficient for one of these. It's not a necessary step, but I think it simplifies the work that you're doing. And so what I'm looking at here, just by glancing at it, it looks like that I could take this third equation, and if I multiplied the second equation by 2, I'd have 10x there. This would be 11x, so if I subtracted them, I could achieve that goal of just having x being 1, the coefficient of x being 1. And so my first step is going to be to take the third equation, and I'm going to subtract twice the second equation. And so I'll just rewrite the work here. I have the third equation. I'll go 11x plus 2y plus 4z equaling 23. And then I'm going to multiply the second equation by -2, and then I'll be able to combine these. As I multiply the second equation by -2, I get -10x plus 2y minus 10z equaling -54. Now as I simplify this here, I'm just combining the terms. I get this equation, which would be 1x, or x, plus 4y minus 6z equaling -31. I'm going to call this equation equation 4. And I'm going to use this equation then to get rid of the coefficients of these other terms here. In other words, I want to zero those out, just like when you do it with a reduced row echelon form, where you just have the 1 and then you don't have anything here and anything here if we're writing it as a matrix. And so in order to do that, I'll take the first equation. I'll move this up here. I'll take the first equation and I'm going to subtract 4 times equation 4. And so same idea. I'm just going to rewrite this first equation right here. I'll say 4x plus 3y plus z equals 2. And then I multiply this fourth equation by -4. And so this becomes -4x minus 16y plus 24z equaling 124. As I combine those two terms, those two equations, I end up with -13y plus 25z equaling 126. If I've lost you, let me go back here and just do a quick review. My goal was to get just one equation that had the x, y, z in it, and hopefully have this as 1. Once I was able to get to that, where I had an equation that led this with 1, I can use this to eliminate the other equations. So I took the first equation and subtracted 4 times this. That allows me to get rid of that equation, and I can replace it with this equation that just has 2 variables. And so my next step would be to get rid of that other equation. And so on this one, I'm going to take the second equation, and I'm going to subtract 5 times equation 4. Now, as I do that, I'm going to write the second equation. I get 5x minus y plus 5z equaling 27. As I multiply equation 4 by -5, I get -5x minus 20y plus 30z equaling 155. As I add that up, I end up getting -21y plus 35z equaling 185. Now essentially what I'm looking at is this fifth equation here and this sixth equation here. Grab a different marker here. I'm going to circle some stuff. And so essentially I started with this 3 by 3 matrix. I was able to generate these other equations. I've got an equation here, an equation here, and an equation here. I'm going to take these equations that I just underlined, and I'm going to focus on just these two. This is a series of equations. I got 2 equations, 2 unknowns. I can do elimination so that I can get rid of one of these variables, and I can get that down just so I know what z is. Okay? And so what I'm looking at is doing this. I'm looking at just at these 2 equations. I'm going to ignore that one for a second, and I'll come back and explain some more stuff. I'm looking at just these 2 equations. I'm going to take negative 21 times equation 5. I'm going to do plus 13 times equation 6. And what that's going to do, I've chosen to get rid of the y's. So if I multiply this equation right here, this equation 5 by negative 21, that'll make this positive. And if I multiply this equation by 13, it would stay negative. I'll be able to eliminate my y's. And so when I do this multiplication, I want to show you a neat little trick in the calculator. If I turn this thing on here, if I want to multiply equation 5, that's what's right above my calculator here, I can go negative 21 times, and then if you use this second button, and then right here you have the braces. This is a parenthesis, but if I go second parenthesis, it's a brace. If I call that up, I can go second brace. I'm going to use those coefficients from this equation right here, and I'll enter them by saying negative 13, comma, 25, comma, and 126. What that will do for me, it will take this negative 21 and it will multiply by all those numbers. So I don't have to worry about making any sign mistakes or anything. And when I hit enter, it tells me 273, negative 525, negative 2,646. Those would be the coefficients for this first equation that I'm going to write here. And so I'm simply going to take that and I'm going to write it as 273y minus 525z equaling negative 2,646. And I'm going to do the same thing with that 13. See, I want to do 13 times equation 6. So once again, on my calculator, I know you can't see this real well, but try and bear with me here. I'll go 13 times second parenthesis, and then I'm just going to call up these coefficients that are here. So that would be negative 21, comma, 35, comma, and 185. Because the numbers are so large, I can do all that multiplication in one step. I simply hit enter, and notice that this would produce a negative 273y, a positive 455z, so I'm just putting those variables back in there, and then the response to that was 2,405. Uh-oh, did I type a wrong number in there? Oh, that was at 182. Oops. And so if that's 182, when I multiply that, this would be 2,366. Now when I combine these 2 equations up, this becomes negative 70z equaling negative 280. So I'm going to solve it. This is easy to solve. I divide both sides by negative 70. And it looks like z will be 4. Now, let me clean up the work a little, and I'll try to explain what I'm doing here. So I'm going to take this first equation, and I'm going to write it as a matrix. So this would be 1, 4, negative 6, and negative 31. There's the first line of my matrix. I can take either one of these equations that had 2 variables, either take equation 5 or equation 6, it doesn't matter, and I can plug that in there. So that would be a 0, a negative 13, 25, and 126. And then because I got this solved all the way down for z equal 4, that would be a 0, 0, and 1, 4. So it has that idea of almost a reduced row echelon form, but it doesn't go all the way. It doesn't have ones all the way across. And that essentially is what I'm wanting you guys to show. I want you to be able to solve a system of equations. So now when I look at this, I can simply work backwards. I know that z is equal to 4. If I go to this second line, I know that I would have negative 13y plus 25z, but now I know what z is. Z is 4, so I can go 4 there, equals 126. So through a series of substitutions, I'll be able to solve for z, then for x, and then for z, then for y, and then for x. So I have my z. I'll be able to solve for y here. I simply say negative 13y plus 100, 25 times 4, equals 126. Move that 100 over, so negative 13y would equal 126 minus 100 would just be a 26. Divide by negative 13, and y would be negative 2. Now to get to the x, I can go back to this first equation, which was represented as x plus 4y, so it'd be 4 times y is negative 2 now. And then I have this minus 6 here, so I go minus 6 times, well, z is 4, so I put my 4 there, and it equals negative 31. And so just by solving this, I can tell you what x would be. I can go x minus 8 minus 24 equals negative 31. X minus 32 equals negative 31. Move the 32 over, so x would equal negative 31 plus 32. X would be 1. That allows me to solve the system of equations by hand. I have that 1, negative 2, and 4. So my solution will be 1, negative 2, and 4. X, Y, Z.